All right, yo. So by now you should have time to have written down your starter off the board. So we're gonna go through the starter. So starter is on measurement, so it's just a refresher from what we've been covering. Okay. So first one says, what is the unit for distance? Remember, we're talking about units, not particular numbers. So for that one, you should have got meter. So number one should be E. All right, number two, what is the unit for volume of solid? So you should know volume of a liquid is in milliliters. So now you're looking for volume of a solid. So your answer for that one should have been D. Okay. So it should have been D. So centimeters cubed. Okay, 3. What is the numerical value for kilo? So remember, numerical deals with numbers. So there's only one answer choice that deals with numbers, and it is A. So remember, kilo is 1,000. And 4, what is the length between 2 points? So length between 2 points should be your distance. So between point A and B should be your distance. And 5, the amount of space that matter takes up is called what? So your answer for that one should have been C. All right, should have been C. So make sure you have those down. So you should have had E, D, A, B, and C as your answer choices. All right, so today we are going over your last set of notes for waves. So last set for Unit 7. So remember, you will have a quiz on this tomorrow, okay? So we're going to review a little bit, then we're going to take your quiz on it, okay? So the last set is on the electromagnetic spectrum. So we've already talked about electromagnetics. So remember, it has to do with electricity and magnets combined with each other. So you're creating electromagnetism. So we're going to talk about the spectrum that it has along with it. So your essential question for today is, what causes electromagnetic waves? So we're going to go over today. So I know you can't see this, but it is just the definitions. So it says the electromagnetic waves is a wave produced when electric charges vibrate. Okay, so this is able to travel through space, which means there is no medium required, which means it does not go through anything. It's just floating out there in space. It's the wave that goes out through space. So it doesn't go through like glass or plastic or wall, anything like that. So while it's in space, it does travel at the speed of light. Okay. So your electromagnetic spectrum. Let's see if I can get this blue up so you can see it. There we go. So this spectrum is an entire range of EM waves, which is electromagnetic waves, wave frequencies that goes throughout, okay? So they range from high frequency to low frequency, or long wavelength, short wavelength, different things like that. So for right now, you should know that if you have a high frequency, then you should have a what? If you have a high frequency, what should you have? You should have a short wavelength. High frequency means it's going to come a whole lot faster, so therefore it's going to have a shorter wavelength, okay? So we're going to go through these here. So the one with the lowest frequency, which means it has the longest wavelength, is going to be radio waves. So you have radio waves again, lowest frequency, longest wavelength, and therefore it will have low energy with it, okay? So this here is an example of that is radios. AM radio, FM radio, things like that nature. If you ever pay attention to the radio, once you get a certain distance from it, like if you were to use a radio station here in Robeson County, Lumberton has one, Roland has one, the further away you got from that particular radio station, and therefore you would hear it statically a little bit. So that is the reason why, is because of that wavelength. It is very long, but it does not have a high frequency with it. All right. Next one you have is microwaves. Everybody should know what a microwave is. Microwaves actually do the same thing that a typical microwave in your house does. So again, the further that we are going down the list, the shorter your wavelengths are actually going to become, okay? So a microwave actually has a shorter wavelength than radio waves. So again, if it has a shorter wavelength, then therefore it's going to have a higher frequency. Okay, so shorter wavelength the further we go down, higher frequency the further we go down. So the first one on this spectrum is going to be radio waves. After that, you will have microwaves. Okay. After your microwaves, you have infrared waves. So infrared waves have a higher frequency than radios, which means that you're going to have a shorter wavelength than radios as well. So when you have infrared, I mean, some people might have infrared heaters at home where it actually lights up bright red. That again is a type of heat. So therefore it is an infrared wave that actually is coming out of that particular heater. All right. Remote controls use an infrared wave. Years ago, they might have used like little lasers or type deal. Now they use infrared waves. Those waves actually get there a whole lot quicker and things like that. And also satellites. You have some satellites that use infrared waves, like heat detection, things like that. So they use infrared waves. All right, the next one you have is visible light. So with visible light, this one here is going to be the only wave really that you can actually see with your with the naked eye. So when people see visible light, think of if you're looking out through the sun and you actually pull up rain or water, things like that. When it rains and then the sun pops out, what actually happens? You should see a rainbow. So that rainbow is actually the visible light that you see, okay? So this here is waves that actually break into light colors. And each one of these colors have a different wavelength. That way you can be able to detect which one is which, okay? So you might have heard the acronym Roy G. Biv. That's where it comes from. So Roy is going to stand for red. O is going to stand for orange. Y is going to stand for yellow. G is your green. B is your blue. Indigo is your I. And violet is the V. Okay, so Roy G. Biv. And that is just your light colors that you see with that wavelength. And again, visible light will have a higher frequency than infrared, microwaves, and radio waves. And again, they do have a shorter wavelength than these up here. But each one of these colors have their own wavelength, okay? So each one has their own wavelength. Our next one we have is ultraviolet. You've probably heard of ultraviolet rays for a long time. Ultraviolet rays do come from the sun, okay? So therefore, you should know that it does cause sunburns. It does help your body by getting it. It can produce vitamin D for your body. It can kill bacteria. And it is absorbed by fluorescent materials, which means bright colored materials, okay? That is ultraviolet. And again, this one here does have a higher frequency than visible light, which means it does have a shorter wavelength with it. Okay, our next one is X-rays. Everybody, probably half of you have already had X-rays done in your life. When you go to the dentist, you have an X-ray done of your mouth, your teeth. Okay? So X-rays do have a higher frequency that can travel through your skin. All right? So a higher frequency that travels through the skin, it can be turned on and off. Your X-ray machines can be turned off. Okay? So again, X-rays do show you bone images, and they use X-rays for radiation treatment. Okay? So over a period of time, you should remember that when you are going to have X-ray done, especially at the dentist, they put a lead vest on you. That lead vest is there to absorb that X-ray wave, so you doesn't that waves do not get in your system. Okay. If you know somebody that's went through has had cancer and they went through radiation, that radiation therapy is that they're using these X-rays. Okay. So going through trying to kill out your system, killing out those cells that are in your system. All right. Next one we have is gamma rays. Gammas is your last one. So gamma rays have your highest frequency, shortest wavelength, and they also have the highest energy levels. Okay. Gamma rays are very dangerous. They are actually your most damaging wave, and it is produced by nuclear reactions. Okay. So the only way that you can actually stop a gamma ray from actually coming out or getting close to you is that if you had lead or very, very thick concrete can actually stop that. So that's if you actually know anybody that's been around a nuclear treatment plant or works in a nuclear treatment plant, that nuclear is actually in a concrete container that is about maybe a foot, 6.5 to a foot inches thick. So that way that nuclear energy does not seep out of it. Okay? So those is your spectrum. So it goes from radio waves, microwaves, infrared waves, visible light, ultraviolet, X-rays, and gamma rays. Okay? Alright, so with just electromagnetic waves, if you were to have a transverse wave without a medium, which means it goes through empty space, so remember it will move just like this, okay? So remember this is a transverse wave. Transverse wave has little curves. It moves at right angles, alright? So with these electromagnetic waves, they travel as vibrations in electric and magnetic fields. And they do have some magnetic and some that electrical properties to them, okay? So they're going to have electric field and a magnetic field with it. So that's what it would look like. So quick fun fact here. So it says an electromagnetic waves travel very fast. So around 300,000 kilometers per second, which is the speed of light. So it says at this speed they can go around the world 8 times in 1 second. So that's how fast those electromagnetic waves travel. Alright, so this here is just an example of your electromagnetic spectrum. So again, radio waves for the radio tower, microwaves for using a microwave at home, or if you look at this example here, you can actually see the guy on a telephone or a cell phone that actually uses a microwave. You have your infrared rays. This person here is using a toaster, heating up toast or bread. Alright, then you have your visible light, which is the rainbow that you see, Roy G. Biv. Ultraviolet rays is coming from the sun with the lady tanning here. X-rays is using the X-ray machine. And then your gamma rays, there's actually a little barrier back here that's cut off. But it is like a nuclear power plant back there in the back. Okay. So this here is just talking about the size of those particular waves, okay? So if you're looking at it, again, very far left is a long wavelength. So it's very, very long. So the farther left you have is a long. The farther you go to the right, it does become shorter. So your very first one at radio waves. So this is about the size of this particular wave. It's about the size of a building. So size of a building. And then the further down, you can actually see how it decreases in size. So it goes from buildings to humans, to a size of a honeybee, then the size of a pinhead, a protozoan, which is a type of bacteria, then a molecule, then an atom, and then an atom's nuclei, which is the center part of that atom. All right? So it lets you know the sizes of how they start out versus how they finish, these particular waves. You want to draw that. All right, global positioning systems, your GPS. Everybody should have GPS on their phone. So this here does measure the time it takes a radio wave to travel from several satellites to the receiver, determining that distance for each one of those satellites. So again, we talked about satellites a while ago. Satellites use which type of wave? Who can remember? So remember, satellites use, some of them use radio waves, depending on what kind of satellite you're using. Some of them use their infrared waves, okay? Majority of the ones that are in space using radio waves, okay? So if they have radio waves, this means they have a very long wavelength. So this here would be an MRI machine. So magnetic resonance imaging. So this here uses a short wavelength or short wave radio wave with a magnet to create this particular image. So this is where you get in that machine and it actually spins around you every so often. So you're taking that magnet and that magnet's actually going around you in circles, creating this particular image for your body. And all those does use is a radio wave. I'm talking about microwaves. So, fact here about microwaves. So, did you know that when you're actually using microwaves that your food actually isn't heating up? Okay? So, listen to this. It says, waves transfer energy to the water in the food, causing it to vibrate, which then transforms that energy into the form of heat to the food. So, your food, the material you're actually eating is not actually heating up. It's actually the water inside of your food that is heating up. Okay? They're actually heating up the water inside of it instead of the actual food. So it does take that type of transfers. Those waves actually transfer the energy into becoming a heat energy, which actually heats up the food itself. Radar detection. So using a radar gun. All those use microwaves. You have your infrared, which has a shorter wavelength and higher frequency than microwaves. So this here would be using an infrared satellite. So it actually picks up warm objects that are given off. A thermogram, again, also uses infrared. So think of infrared actually using heat, okay? Anything dealing with heat would be infrared. You have your visible light, which is electromagnetic waves you can see. Next one we have is ultraviolet. So again, ultraviolet is used to kill bacteria. So back when COVID first happened, a lot of people started producing different types of lights that they would put in rooms in order for it to kill bacteria, or in hospitals they would put them in rooms to actually kill the COVID cells that were actually in that room of a COVID patient, okay? So they'd put those lights in there. Those lights would actually circle around the whole entire room, and they would stay in there for a few hours. So those lights would actually give off that particular wave, that ultraviolet wave, to actually kill the COVID bacteria inside of that room. So that's how that happened. And they still use them still to sterilize people's equipment and things like that. You also have the ultraviolet rays that can cause skin cancer. Remember, it does come from the sun. That's why it is very important that you use sunblock to help prevent it. Alright, so if you see anybody with any kind of these spots like this, let them know that it's warning for skin cancer, okay? Yes, I know that do look nasty, okay? Talk about X-rays. So X-rays do have a lot of energy, and they can penetrate most matters, which means they can go through most matters. So this here is an example of an X-ray of a bat. So bones and teeth is what it picks up. Does anybody know? Take a guess at why it does pick up teeth. So your teeth are actually made up of the same thing your bones are made out of, which is a thick cartilage, okay? So that's why it does pick up teeth. That's why your teeth are very strong, because they're made of the same material that your bones are made out of. So again, this is this lead vest that they use to put on you when you're going to have an X-ray done, so it can absorb those rays. All right, and then also some engineers use X-rays as well. So if you're helping with architecture or building design, some engineers actually use X-rays to look at the foundation of structures to see how sturdy it actually is, or to detect a crack inside of it, okay? And then your last one again is gamma rays. They are your shorter wavelengths. They do have your higher frequencies than anything else. So gamma rays also carry the highest amount of energy. So this here would be a machine that you would use to help kill cancer cells. So again, it is very harmful to use. And gamma rays again also come from nuclear reactions. So if you have we were to have a nuclear attack here, then it would be very dangerous for us because of those gamma rays coming out of that nuclear cells. All right. So now I'm going to let you write your notes. So I'm going to let you write your notes out. So let me switch over. All right, so I'm going to let you write down this spectrum here. So write down this spectrum. So this here is your electromagnetic spectrum diagram, okay? So again, if you can look at it, you can tell that it does start out with radio waves, then it goes to microwaves, infrared, your visible light, ultraviolet, X-ray, and then gamma. And then again, I got your key points down. Further to the left you are, it does have a longer wavelength, lower frequency, and lower energy levels. Further right you go, you end up with a shorter wavelength, higher frequency, and higher energy off of it. Okay? And down here is your ultraviolet. Okay? So this here, I mean your visible light spectrum. So this down here is your visible light. So go ahead and write that down. Now we'll zoom in some more for you. Alright, so by now you should have that written down. So I'm going to move it down some. So I'm going to go through and break each one of these here down again. So let you see it. So go ahead and do those 3 there. All right, next ones. Again, I will post these in the slides if you do not get to write all of them. Okay. All right, so your next ones are going to be these. We'll give you some time to write those. Alright, give it about another minute. Finish writing this. Alright, so now next part is going to be some examples. The last part's just going to be examples. I'm going to go over some examples. So what I want you to do is, with these examples, I want you to tell me your goal is to tell me which one of these has either the longest length. So you're going to have an answer choice for A, an answer choice for B, an answer choice for C, and also an answer choice for D. So that'll be for number 1. And then also for number 2, you're going to do the same way. You're going to tell me which one of these have the highest frequency between the two. So again, A is going to have its own answer, B is going to have its own answer, C is going to have its own answer, and D is going to have its own answer as well. Alright, so going over this here. So looking at your first one, it says which has the longest wavelength. So for the first one, whichever has the longest wavelength, you should have put A. Because if you go back and look at your spectrum, so going back, look at your spectrum up here. Remember, longer wavelengths are to the left, shorter wavelengths are to the right. So you are comparing blue and red, okay? And we are looking for the longest wavelength. So for blue and red, therefore, should have red. Answer choice red. Okay, so the only thing you have to do is just circle it. All right, next one, it says which one is longer between UV or gamma. So UV is over here. Gamma is over here. So your answer choice for that one should have been UV. Looking at C, you are comparing radio waves and infrared waves. All right, radio has the longest wavelengths. All right, so far left. So therefore, the answer for that one should have been radio. Then for your next one, you're comparing microwaves and X-rays. Okay, microwaves and X-rays. So looking at microwaves, then looking at X-rays. Microwaves would definitely be your answer for that one. All right. Next question said which has the highest frequency. Remember, higher frequency will be on this side over here, which means you're going to have a shorter wavelength. So now you're going to compare your orange and your violet. So orange on this side, violet on this side. So your answer for that one should have been violet. All right, looking at B, you're comparing microwave and X-ray. So microwave, X-ray. Again, doing higher frequency, so that answer should have been to your right. So you should have had X-ray. All right, next one you have is yellow or indigo. So yellow versus indigo. Indigo is more to the right, which means it has that higher frequency, so therefore you should have had indigo as your answer. And the last one, you're comparing radio or UV. So radio waves or UV rays. Ultraviolet rays are more to your right, so therefore your answer should have been UV rays. Okay? So now what I want you to do, you have a worksheet. You have two sides to it. One side of it is called Wavestown, which looks like this. It is called Wavestown. So what I want you to do, I have numbers in this pictures. And you have words up on you, have lines up on it here as well. So what I want you to do is match these numbers up. Okay? Match your numbers up. So I'm trying to zoom in so you can actually see your numbers. All right. So your number one, so just draw when you get your paper. So I'll pause a little bit and let you get your paper. All right. So if you already have your paper, just go ahead and match them up. So your first one is over here at your taxi. So number one is going to go right here at your taxi. So just write number one. All right. Number two is up here, beside your microwave. Okay. 3 is over here at the tanning booth. 4 is up here at the top. 5 is down here where the letter shades is at. 6 is over here where this guy, it looks like a skeleton. And then 7 is the word nuclear medicine, okay? So, you have to color this. It has to be colored neatly in order for you to get full credit for it, okay? So, neatly for full credit. And again, once you match these numbers up, go ahead and color it. And then you also have a worksheet on the back, okay? You have roughly about 20 questions or so on the back. When you get through numbers 13 through 20, just tell me whether it's true or false. You do not have to go through and rewrite the statement if it's true or to make it true. So just tell me whether it's true or false, okay? If you have any questions about this, please go over and see Mr. Tim, next room over. And again, if you did not get finished writing your notes, I am going to post them in the slideshow as well, okay? So I will see you guys tomorrow. And remember, you do have a quiz on Unit 7 tomorrow for this as well. All right? Have a great day.